Let's learn about fractional exponents. Mark my words, you harness that negative power of yours and you could make it to the top, just like me. Notice this is x to the 3 and this is x to the negative 3, so we're going to see what happens with that. On our agenda, we're going to rewrite an exponent in radical form. We'll simplify with radical exponents, and we're going to apply the rules of exponents. The good news is the rules of exponents are the same. We're just going to have to deal with the fractions. So let's get ready. You're going to need a notebook and a pencil. And here we're going to rewrite an exponent form. So this is in radical form, and you can see that my index is 3. So whenever you have an index, that's going to go into the denominator of your exponent. So this becomes x to the 1/3. If we had the square root of x, then that's going to become x to the 1/2. If we had the 4th root of x, then that's going to become x to the 1/4. So the index goes into the denominator of the exponent. Here we have x to the 1/4, and we want to rewrite it in radical form. So the denominator becomes the index. So this becomes the 4th root of x. You need to know how to be able to write back and forth between the two forms. Power to a power. This 2 is supposed to be a squared. So we have x to the 1/3 raised to the 2. So we have a power raised to a power, which means we multiply. Now be careful when we do 1/3 times 2, that's really 2 over 1. And you multiply the 2 to the numerator, not the denominator. The denominator is just 3 times 1. So this becomes 2/3. So this is x to the 2/3 when you multiply that. So just think about how you can pull it apart and go between these two. X to the 2/3 is the same as x to the 1/3 squared. We're going to want to remember that because we're going to want to pull the denominator in like this so that we're making it smaller first, and then we'll make it bigger when we square it. So let's look here as an example. 8 to the 2/3. So I'm going to pull the denominator in, and I'm going to rewrite this as 8 to the 1/3 squared. We just separate that 2/3, and again that works because 1/3 times 2 is 2/3, so I haven't changed the problem at all. Now I'm thinking of this 8 to the 1/3, which is the 3rd root or the cube root of 8 squared. So I went from exponent form to radical form, and the cube root of 8 is 2, and 2 squared is 4. So 8 to the 2/3 equals 4. Let's look at 16 to the 5/4. So I'm going to pull my denominator in and make it 16 to the 1/4 to the 5th. I'm making 16 smaller, and then I'll make it bigger with the 5. So 16 to the 1/4 is the 4th root of 16, and then we're going to raise it to the 5th. The 4th root of 16 is 2, because 2 times itself 4 times is 16. So this becomes 2 to the 5th, which then is 32. 9 to the 2/3, 9 to the 1/3 raised squared is the square root, or sorry, oh, that's an ugly one, the cube root of 9. Yeah, let's switch this one. We'll make it a little better. 9 to the 3/2, because there's not a perfect cube of 9. What I meant was the square root of 9 cubed, which is 3 cubed, which is 27. Rewrite in radical form. So if we have 8 to the 1/3 squared, we saw that we could write that as the cube root of 8 squared. So you could go with the parentheses around it, or you could do the cube root of 8 and then put the square inside. I think this way is easier because you're making it smaller and then bigger. This would be the cube root of 64, which is still 4. We still get the same answer, but they are the same thing if you put the top numerator on the outside. So this could be written as the 4th root of 16 to the 5th, or the 4th root of 16 to the 5th. And we'll keep this one as it's written, but it would be the cube root of 9, whole thing squared. Rewrite in exponent form. So remember, the index is your denominator. Whatever your exponent is your numerator. So this becomes 64 to the 2/3. This is 81 to the 3/4, 32 to the 4/5. Negative exponents. This goes back to the first cartoon. So remember our exponent rules. If you have a negative exponent, you're going to do the reciprocal. So this becomes 1 over x to the 10. Let's see what happens with a negative fraction exponent. So this becomes, first I'm going to do the negative. So 1 over 25 to the 3/2. Then I'm going to rewrite that so it's 1 over 25 to the 1/2 cubed. Something to the 1/2 means it's the square root of 25 and then cubed. The square root of 25 is 5 and then cubed. So the answer is 1 over 125. Multiplying. Remember, we can multiply radicals. The square root of 2 times the square root of 3. If they have the same index, these would both be square roots. Then we would get the square root of 6. Notice here that my indices are different, so I cannot just multiply underneath, but what I can do is switch to exponent form. So this one becomes x to the 4/3 times x to the 5/4. Now I have, so it's multiplication, and my base is the same, they're both x's, so I can add my exponents. So now we're looking at 4/3 plus 5/4. Remember, when you add fractions, you need to get a common denominator. My common denominator here will be 12. And 3 times 4 is 12, so that means I have to multiply my numerator times 4, because 4 over 4 is 1. So this becomes 16. 4 times 3 is 12, so 15 in the numerator here. And we have 31 over 12. That's my exponent, and that's my answer. Let's look at division. Again, we have the same base of x, but we have different indices. So I'm going to rewrite them both in exponent form. So we have x to the 3/5 over x to the 7/4. My rule for division is subtraction. So now we still have to get a common denominator when we're subtracting fractions. In this case, the common denominator between 5 and 4 will be 20. And I do 5 times 4, so I have to do 3 times 4, which is 12. 4 times 5, so 7 times 5, which is 35. So this is going to be a negative 23 over 20. So that becomes x to the negative 23 over 20. And then remember, we don't want to leave any negative exponents. So this is going to become 1 over x to the 23/20. So our rules when we're working with exponents that are fractions is when you multiply or divide, you must get a common denominator first. So here we have the same base, and then we're multiplying, so we're going to add our exponents, get a common denominator. When you divide, you're going to subtract, you have to get a common denominator. And then when you have a power raised to a power, you're multiplying, and in this case, the m only goes to the numerator because it's m over 1. Nice job.